Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we are going to discuss about multi-stage amplifiers. Multi-stage amplifiers, two or more amplifiers which are connected. In order to increase the gain of the AC signal, we go in for multi-stage amplifiers. The overall voltage will be calculated by getting the product of individual gain of the amplifier. For example, if AV1 is the voltage gain of an amplifier 1, AV2 is the voltage gain of second amplifier, AV3 is the voltage gain of third amplifier, then the overall voltage gain of the amplifiers which are connected together is AV dash is equal to AV1 into AV2 into AV3. So for n number of amplifiers connected together, we have AV dash is equal to AV1 into AV2 into goes on up to AVN. So what is the need of going in for multi-stage amplifiers? In order to increase the gain of the AC signal, we go in for multi-stage amplifiers. So in multi-stage amplifiers, we have two types by which there are two different ways by which you can connect the amplifiers. One is if the amplifier is connected end to end, that is transistors connected, the output of one transistor feeds the input of the other transistor, then that type of connection is called cascade connection. And the kind of amplifier is called cascade amplifier. I repeat again, if the transistors are connected in a chain with the output of each transistor feeding the next, then it is called cascade connection. In this kind of amplifier, the amplifier load is typically connected in a horizontal chain, that is from left to right. The overall gain of the cascade amplifier is the product of the gains of each individual amplifier. So the connections can increase the amplifier's voltage gain, but also decrease the bandwidth. That is, the gain may increase, but at times the bandwidth may reduce. This is about cascade amplifier. The next type of connection is cascode type of connection. Here the transistors are connected in parallel and they are stacked vertically on top of each other. I repeat again, the transistors are connected in parallel and stacked vertically on top of each other. The cascode amplifier is made up of common emitter input stage and a common base output stage. Here, in this type of cascode connections, the kind of multi-stage amplifier gives wide bandwidth and a moderately high input impedance. High input impedance. Yes, so in cascade connections, we have a increased voltage gain, but the bandwidth may be low. In cascade connection, it has a wide bandwidth and has high input impedance. So we'll discuss about the nature of connections of cascade. So in cascade connection, I'll try to draw a circuit of cascade. Yes, with. So why am I showing the videos without direct images is while drawing the circuit, it is very easy for you to understand it step by step instead of rather depicting everything from direct images. So first I start from the input side, directly I go to the base, and from the base if any biasing is given, directly go to the biasing circuit, then the emitter part, and we'll hold on this. So this is Vs, Rs, the coupling capacitor. R1, R2 are the voltage divider bias circuits. RC1, RE1, CE1, all these are mentioned on about a single amplifier circuit which we are familiar with. Now the output is across collector 1. The output of the collector 1 is taken and connected to the base of the second transistor. Yes. The emitter terminal is connected over here, E2, collector terminal here, and it is also connected to a common grounding of minus 5 volts P minus, and here the VCC supply has to be given. For example, V plus 5 volts necessarily be the same voltages with RE2, and here it is coupled with a capacitor CE2, a coupling capacitor CE, the output voltage across here, and an RL resistor. Yes, so from this we find that here this is a single stage amplifier. The output of the collector is taken and coupled to the base of the next transistor. So this way it is called as cascade connection. The voltage gain AV is equal to AV1 into AV2, where AV1 is the gain of the first amplifier and AV2 is the gain of the second amplifier. Yes, this is about cascade connection. The next type of multi-stage amplifier connection is cascade connection. In cascade, as I said already a few minutes back, the transistors are connected in parallel. Yes, we'll try to draw parallel circuits with the emitter of one transistor being connected to the collector of other transistor. So in this manner. So this is the basic understanding. I hope you will be able to complete the other connections. Yes, I've shown the part of the connection separately with a different color. Yes, and the rest part, let us give source to Q1 transistor and let this be Q2 transistor. RE1, CE1, coupling capacitor 1, and this is the source voltage. Yes, and for the purpose of biasing, R1, R2, R3. Yes, and now we have completed the circuit connections. Yes, this is the capacitor connected to the base of the transistor. Here R1 and R2 provide the voltage divider bias for Q2 transistor. R2 and R3 provide the voltage divider resistors for Q1 transistors. Here we are supplying only one source voltage. The source voltage input voltage is given to the base of the Q1 transistor. Yes, and the output is collected across the collector terminal of Q2 transistor through a load RL. Yes, this is the way the cascade connections are connected. Two transistors are connected in parallel. The emitter terminal is connected to the collector. That is, the collector output is taken and connected to the emitter terminal of the second transistor. And the collector is collected across the second terminal of the second transistor Q2. Yes, the voltage gain of cascade connection here is given by minus Gm into Rc parallel to RL. AV is equal to minus Gm into Rc parallel to RL. Yes, so this is the Rc, sorry, this is the value of the Rc parallel to RL, the equivalent value of this is taken, and the Gm is the transconductance. Thus, this gives the average, the voltage gain of the cascade kind of connection. There are other ways of going in for multi-stage amplification configurations also. When we connect one transistor with the other, yes, the first type of, we need some additional elements to connect them. The part of the connection alone we'll discuss here in this section. If this is transistor Q1, plus VCC, this terminal is connected to the base of other transistor Q2. Here we could see transistor Q1, transistor Q2. A set of RC coupled elements are connected for the purpose of connecting two transistors. This kind of coupling is called RC coupling. Yes, we use R and C components to couple these transistors. In the earlier cascade connection, we had voltage divided bias connections, and we have another kind of second type of coupling using transformers. Yes, using transformers we can couple. Yes, I have a transistor here. The collector terminal is taken and fed to the primary part of the transformer. This is a transformer. The source voltage Vs1 is given to the transformer here, sorry, to the base of the transistor through RB resistor. Base biasing is given here. The primary, this is the collector terminal, the primary of the transformer is connected to the collector terminal, so which induces the voltage to the secondary of the transformer, the secondary being grounded, and the other terminal is connected to the base of the other transistor Q2. Yes, it is connected to the base of the other transistor Q2. So this kind of connection is called transformer coupling connection. This kind of connection is called transformer coupling connection. The source voltage, the signal to be amplified is given here to the base of the transistor 1. The collector terminal is taken and connected to the primary of the transformer, wherein the secondary of the transformer is connected to the base of the transistor 2. This is called transformer coupled kind of connection. Yes, now we are moving into another special kind of connection. The third type is direct coupling. Darlington kind of connection. Yes, it is a transistor Q1 supplied with VC1 with a resistor. The collector terminal of transistor 1 is taken and connected to the base of transistor 2. The output being collected across the collector terminal of the second transistor. I repeat again, a signal to be amplified is fed to the base of the first transistor. The collector output is taken and fed to the base of the second transistor, which amplifies and gives the output at the collector end of the second transistor. This kind of connection is called direct connection, and with a small modification, this emitter terminal, if directly is taken and connected to the base of the second transistor, then it is called Darlington. This configuration is called Darlington kind of multi-stage amplification configuration. So in this video, we have discussed the different types or the ways which you could go in for multi-stage amplification. The most commonly used ways of connections are cascade connection and cascade connection. In cascade connection, the voltage gain increases with a reduction in bandwidth. In cascade connection, the transistors are connected in parallel. Hence, the bandwidth increases but shows a decrease in the AC output impedance. Along with that, the ways by which they are connected are also explained with the three different elements called RC coupling, transformer coupling, and the other direct connections. Directly without using any additional elements, we could take the emitter terminal and directly connect it to the base called Darlington connection, or the collector terminal is taken and directly connected to the base is called direct kind of coupling. Thank you.